Hi guys, Mrs. Anderson back, and I hopefully figured out a new and improved way to video these lessons. So we're not going to do a quiz over the end of, what are we on, chapter 8. So this week we're just going to get right into section A in the back of the book. Obviously this is the 7th grade material, so if you need to reference Khan Academy for any reason, make sure you're going into these 7th grade lessons. But this is just an overview of section A. We're going to be adding and subtracting rational numbers, and so it's kind of a shorter chapter, but we're going to spend pretty much just 3 weeks over this section, and then we will spend the last 3 weeks over section B, and that's it. We would have covered pretty much everything for advanced math. So I'm going to get started right on page 504. So here it's talking about absolute value. Absolute value of a number is the distance between the number and 0 on a number line. The absolute value of a number A is written as this, and it has these 2 bars around it. All absolute value means is how many places until you get to 0. So you could be at 4, and it would take you 4 hops to get to 0. So the absolute value of 4 is just 4. But if you're at -4, it's still going to take you 4 hops to get to 0. So the absolute value of -4 is still 4. So I just have a couple notes to go over, and again, feel free to write this in your ISNs or your just a regular notebook. So absolute value is the distance between the number and 0 on a number line. In other words, how many hops is it going to take you to get to 0? And these are called the absolute value bars. So and this is how we would say this. The absolute value of -2 is 2. Because on a number line, if you were at -2, it would take you 2 hops to get to 0. 2 jumps, 2 spaces, however you want to say it, to get to 0. So the absolute value would be 2. And then the absolute value of 8 is still 8. It's still going to take you 8 hops, 8 jumps, 8 spaces to get back to 0. So one thing to remember is just any number inside the absolute value bars is positive. So if you have any negative, it's just going to turn to a positive. If it is a positive, it's going to remain a positive. Okay, so let's look at some examples. So the absolute value of -3. So if we're at -3 in a number line, again, ask yourself, how many hops, how many jumps does it take to get to 0? 1, 2, 3. So the absolute value of a -3 is 3. We can do this with rational numbers, which are just fractions or decimals. And here if we're at 1 1/4, again, how many jumps or hops to get to 0? Well, there's 1/4 of a jump and then another 1/2 and a 1/2, so that would be 1 1/4. So again, absolute value of 1 1/4 is just 1 1/4. So I have these 3 numbers on my notes. So let's go through this. So I always try to make my absolute value bars a little bit higher, longer than just your regular space, so it doesn't get at all confusing with 17, 171. Make sure your bars are a little bit higher and lower than your regular numbers when you're writing. So the absolute value of 7 is just 7. Now look at number 2. This negative is outside of the bars. So 5/3, just keep it as an improper fraction. How many hops to get to 0? 5/3 hops to get to 0. But since this negative is outside the bars, that negative sign has to remain. So this answer is going to be negative 5/3. Now for number 3, since the negative sign is inside the absolute value bars, everything inside, remember, turns to positive. So this will just be positive 2.6. And that's it. We can go to the next page. We can compare rational numbers just like we have with integers or regular numbers. So negative 2 and 5/10 and 3/2. Well, if you graph both of those on a number line, which one is larger? Well, this number is farther from 0. Remember, the bigger numbers are going to be farther away from 0 over here. On this side, they're going to be getting less value. So this number is the 2.5, because remember, this is a negative 2.5, but when you do the absolute value, that's going to be placed over on the positive side. 3/2 is just 3/2. It doesn't have any absolute value bars, so you're just going to graph it. 3/2 is written as 1.5. That would be here. So obviously we can say that the negative 2 and 5/10 inside the absolute value bars is going to be greater than 3/2. So let's just do 3 more. So absolute value of 9, I like to just kind of rewrite my value, my answer, underneath it. So this is going to be 9. Absolute value of negative 9 is still going to be 9. So 9 is going to be equal to 9. So this would be the answer right here, equal to. Now here we have rational numbers because they're fractions. This negative is on the outside of the absolute value bar, so this number is going to remain negative. This number is going to remain negative. So now we got to think a negative 1/2 and a negative 1/4. And if you need to visualize that on a number line, they're both negative. So obviously here's negative 1. That would be negative 1/2, negative 1/4, negative 3/4. So that we can say this one is going to be greater because it's closer to the 0. So he gets the 2 dots, he gets the 1 dot, connect them. That's going to be a less than symbol. So we would say the negative absolute value of 1/2 is less than negative 1/4. Here we have a positive number. Inside the bars would turn to a positive 4.5. But since this is negative is the outside, that negative has to stay. So a positive number is always going to be greater than a negative number. So we would say 7 is greater than negative absolute value of 4 and 5/10. And just for some vocab, remember integers are whole numbers that can be written as positive or negative. And then rational numbers is going to include a fraction or a decimal. And that's pretty much it for section A.1. Pretty easy lesson. You can head over to bigideas.com and you will have a 10-point assignment in there. So have a great day, guys.